Hello, my name is Cody Fulcher, and I'm going to be showing you guys my final project for the NYU Poly Cyber Forensics class for fall 2013. I made a tool called CellLocator.py. It takes this SQL database called consolidated.db, which is on every iOS device running any version of the operating system past 4.0. Basically, consolidated.db is consolidated. The part they left out is a location library or location database. So it's a history of where you were in devices before iOS 4.3.3. It's all of the cell towers and wireless access points that that device has ever seen. Um, and Additionally, the file is very easily accessible. It's accessible by just parsing, or just from a logical dump of the operating system. After that, you have to get a physical extraction of the device, or a physical dump of the device. Um, so that's a little limit that this has. And additionally, after 4.3.3, it went from the entire history of the phone to only the last 50 or something along those lines. But basically, it has all these tables in it. The ones that are the one that is in particular interest to this tool is cell location. Wi-Fi location is basically the same as cell location, but for wireless access points, cell location is for cell towers. So it has a bunch of fields in it. The ones that are important to this project are MCC, which is the mobile country code. Basically, that tells you what country it's in. MNC, which is the mobile network code. That tells you which wireless network the device is associated with. So if it's not what the device is associated with. I'm sorry, what network the tower is associated with. LAC, which is the local area code, which is like which grouping of towers it's in, and then CI, which is the cell tower ID. So that's which individual tower you're connected to. And then there's also this timestamp here, so we know where and when someone was placed. Now you notice there's also a latitude and longitude already here. I chose not to use these in my tool because the way that they're generated, or like the methodology they use to generate these based on this information, is not clear. We don't know what their database looks like and all that stuff. So we're using a tool called OpenCellID, or an open source database called OpenCellID. And I'll show you how we do that right now. So basically, what we do is what it does is it takes in the consolidated.db file, which has to be in the same directory as it, and it parses out the information we want from it. So it does right here. You'll note there's this limit 10 right here. That's so I can show you guys the demo. If I didn't, because the device I got this consolidated.db off of was a pre 4.3.3 device. There's about 8,000 queries here. Some of them are not usable, so they get discarded. That's what this is. We only want ones with valid cell IDs. Some of them are invalid for some reason. But if we just let it run the full thing, it would take about 40 minutes, so I'm just limiting it to 10 so I can show you guys what it looks like when you run it. And then we ask OpenCellID for where it is. We send it in our array of all the databases, or our list of all the databases, or a list of all the cell towers. There we go. We ask, it's just a simple JSON request. We get it back. It comes back as an XML object. We parse it out, and then make a temporary array to hold it all with the date, which we convert to a readable time format for us. Like I said, it uses the timestamp for consolidated.db is this thing that isn't particularly useful. You'll see this is like November 10th, 2010 or something. So it's not particularly useful the way it is, but luckily we can easily convert it. And then we write it to a comma-separated value file, a CSV file, in the format of date, lat, and long, which allows us to easily analyze and visualize that data. So to run it, you just go to your handy-dandy terminal, make sure you're in the right directory, obviously, and then you just enter Python celllocator.py. You hit enter, it goes, and it tells you how many entries there are, as well as how many you've gone through. Prints it all out when you're done, and then it writes it to a file called locations.csv. And then once you have that file, you can import it into a tool like Google Fusion Tables. This is, I think, actually one of the better tools to do this with. It has a lot of, it's really simple to use. It's free, obviously. It's just a Google product, and it's really, it's actually surprisingly powerful. So you just hit import. This, the one that I'm going to show you guys is actually the test one that I ran. So this one, it contains the whole consolidated .db, so it's a lot larger than this one up here that we just generated. So this locations.csv, you can see, is about 616 bytes. So it's really small, whereas the one that I'm going to show you is 281 kilobits, so it's a lot bigger. So just open it, import it. We'll have comma by default, it's the correct thing. Yep. Next. You can set whatever you want here. It's not really it doesn't affect how you use it at all. Hit finish, it loads it all in. And you'll see in a second when it's done that without even doing anything, it already figured out that it was geolocation data and just puts it on a map for us, which is pretty cool. So this is everywhere that device has ever been, from the time it was upgraded to iOS 4.0 or potentially activated, depending on if it came with iOS 4.0 or whatever, which is cool, but not necessarily super useful, right? Because this is like 2 years or like a year and a half or something of that data. So what we can do is date. It'll tell you the start and end dates here, so you don't filter something that makes no sense, like dates totally out of range. And let's do September 5th to let's go back so it's a little bit shorter at least, to November 10th. Okay, and hit find. There you go. And it removes the other ones, and now we just have these ones. You can narrow it down even more. You could also do, you can also filter by the latitude or the longitude. And obviously if you do a filter by latitude and longitude, you would come up with a range or whatever. And it also does this cool thing here where it will list the occurrences. So 3.42 apparently is the most common occurring one. That's probably like somewhere around, it's probably these right here. No? Anyway, 3.42 is the most commonly occurring one in here, 33.67, whatever. You can click on those and I'll show you them. So right here you spent a lot of time in the Georgia, Alabama area. So you can see there's a lot of like cool things you can do with this. It also has a heat map, which won't be super useful to us right now. Turn that off. Let's see what happens. So you can see a heat map of kind of like where it is, and obviously the more you zoom in, the more useful that heat map becomes. And so yeah, that's pretty much what we have. So yeah, it's basically the tool. Obviously you can use other tools other than Google Fusion Tables to kind of analyze this data. This is just the one that I was thinking of when I made it. It's free and easy to use, but it's the format that the tool outputs in makes it very easily usable in any kind of analysis applications that you might want. So anyway, thanks guys. I hope you enjoy the tool.